Hi, I'm Mads Johansson.
And I'm Mike Cook, and this is our AIIDE paper, Challenges in Generating Juice Effects for Automatically Designed Games. So if you're not familiar with the term juice, we define it in the paper, but juice is a really important part of game design. It's any kind of visual or audio effect that helps convey a feeling of what is happening in the game to the player through feedback from the world. So this is a slowed down clip from Hollow Knight, and as the player connects with this enemy, the game freeze frames, throws out some particles, the player starts flashing, the lighting kind of focuses in on them. All of these small effects help contribute to the feeling of what is going on and the feedback of having contacted with something bad and recovering from that damage. So juice is a really important part of game design. Lots of game developers are in love with juice and juiciness. It's part of their brand. But in something like automated game design, we find that a lot of this research sort of ignores game feel, or at the very least hasn't had an opportunity to engage with it yet. So automated game design is the idea that we can apply AI to the game development and design process. But most of that work so far has been focused on rules, some stuff on visuals, but game feel, to our knowledge, is absent from AIIDE literature. So when we came into this project, we asked ourselves what it would mean to generate game feel for games, and how that fits with this broader idea of designing games with AI. Is it part of the game design process? Is it something AI should be able to do? It feels to us that it definitely should be. It should be something that procedural content generation research and AIIDE is able to consider and look at. So when we got together to do this project, we decided to sort of combine these interests that we had and these two tools that we were building. So the first of these tools is Squeezer. Squeezer is a tool for generating and editing juicy effects in games. It's open source and free. It's designed for Unity, and it's Mads Johansson's work. Mads is the first author on this paper. And it's designed for people to use to sort of manually generate, tweak, and update juicy effects for their own games. So you can see this tree-like effect on the screenshot on the left, where different effects are composited together and edited. You can automatically generate effects according to certain recipes, like randomly give me an explosion effect, or you can design your own one. And Matt has loads of examples. It's a really amazing piece of software, actually. I really recommend checking it out. At the same time, I had been working on a piece of software called Puck. Puck is an automated game designer, kind of a successor to the Angelina series of automated game designers, if you're familiar with them. And Puck was generating games, but they were sort of missing any kind of game feel or even visual presentation at all, really. They look like this. And we wanted to see if we could integrate Squeezer with Puck to give it the ability to generate effects. Now, the way that Puck works is it uses an event-driven system for all of its game logic. So something happens in the game, like the player tapping a box on the screen, and this triggers an event to be created that contains some data about the thing that's happened, and it gets broadcast to all of the different modules and game components that are going on, and they can decide whether or not they want to respond to it. So this is very convenient for automated game design for various reasons. But we also realized that we could use it to sort of integrate Squeezer's effect generation and execution into Puck. So the way that we did this was we have this setup where Puck has this database of game designs. Maybe it pulls one in because it wants to generate an effect set for it. And what we can do is we can look at all of the different effects that can be fired in the game by studying the rules, and then generate an effect for each event that the game can possibly fire. So Puck looks at the game rules, goes through them, asks Squeezer to generate an effect, and we connected Squeezer's recipe templates, like the explosion one that I mentioned earlier, to certain effects. So maybe if you're going to have a piece destroy event, that makes sense to be connected to an explosion template. So we sort of narrowed the possible expressive space there. Squeezer then generates something that is appropriate, sends it back to Puck, and Puck adds it to the game's design, which gets added back to the database. So in this case, a game has been augmented with extra parts of its design, which are these automatically designed effects, where each effect is connected to some kind of event. So whenever a piece is spawned, for example, the effect that is connected to the on-piece spawn event should be fired. So that was one part of getting the sort of effect generation process online. The second part was actually having them show up when the game is played, which was its own set of technical challenges. So when we started working on this, Puck's visualization was very, very basic. Basically, at any time, we can ask Puck to show us what is on the game board, and it uses a visualizer to do this. It basically just draws the contents of the game board on the screen. And what that means is when something happens, like a piece being destroyed, the piece just disappears. There's no effect or anything like that. It was very flat, and in many ways, it made the games hard to play because you often couldn't tell what was changing because the board would just flicker and update when things were happening. So Mass came in and wrote an entirely new visualizer that uses the event system. And what that means is that instead of being just asked to display the entire board at the end of every player action, for example, we now listen for events. And when events happen, we do something in response to that. So if a piece moves, we can animate the piece moving. But it also means that this new visualizer can pull in effects from the game's design, from the generated effect set that we saw on the previous slide, and then play them at appropriate times. So when the destroy piece effect is called, we know that we can ask Squeezer to play the on piece destroy effect. So this was a really nice way of integrating events into sort of Puck very naturally in a way that was sort of very natural for Squeezer as well, because Squeezer has this event-based way of triggering effects. So it worked out really nicely. Now we wanted to sort of get a feel for what impact this system was having. It's a very basic system in a lot of ways, but it's a lot of uncharted territory for us. So we conducted a study, and in this study we used two different games. The first is a well-known human design game called Same Game. You might also know it as the Colors game, which is a single-player puzzle game. And the other is a game called Antitrust, which is a two-player game that was designed by Puck. So we had a mix of games that were existing before and games that had not been seen before. And, you know, we wanted to get some variety in the study. On reflection, this was sort of, there's not enough to sort of draw any conclusions about single player or two player games or anything like that. But it was still really useful for us to think about what it means to integrate the system deeply with the automated generative design process. So we could have just looked at generating effects for human games, but we didn't just want to do that. We wanted to actually think, what would it mean to deeply integrate this with Puck, with automatically designed games? So we had one of each game, and then for each game, we show the participant three versions. So we show them a very basic kind of static version of the game with almost no effect. It has a few simple effects for communication. So pieces do move on the screen, for example, but it doesn't have any nice game feel elements, any fancy particle effects or anything like that. Then we show them a version of the game with generated effects, where Puck has generated a bunch of effects using Squeezer. There are actually three different generated versions of each game, but we only show each participant one of them. We randomly pick one to show them. And finally, we have a designed version of the game with effects that were created by Mass, an experienced game designer, as sort of like the top end of what's possible. And each participant sees these three in a random order, and then each set of games in a random order. So they see all of the same game ones together, but they see them randomized. Some people might see the same game ones second, and the Antitrust ones first, or vice versa. And afterwards, they fill out a survey where we ask them to rate the game's aesthetic and visuals. We kept this phrasing intentionally vague. We just wanted to get a feel for how they were responding to these visual elements of the game. And then we ask a qualitative optional question, why did you select this rating? This was really for our own edification more than anything else. But one thing that surprised us is that the majority of participants filled this in, even though it was optional. So our analysis here and in the paper is mainly for this 10-point scale numeric rating. But looking at some of these sort of qualitative feedback is also kind of interesting. So here are the results. So for Same Game, we had 112 data points. And you can see here, each row is one of the different generated sets of effects. And we show the comparisons and whether they were significant or not. So you can see two of the three generated effect sets were significantly preferred over the version of the game with no effects. But none of them were significantly preferred over the expert version. Although the expert version was also not significantly preferred over the generated effects, which is encouraging. So essentially here, generating effects for Same Game improved the perception of the game and was sort of competitive with our expert design set. For the two-player game, Antitrust, the story's a little bit different. The expert set are all significantly preferred over the generated set, but crucially, the generated set is not significantly better or worse than the basic set. So this had slightly fewer participants and is obviously a very different game. It's a very different experience, which I'll mention in a sec. But the important takeaways for us here is that, first of all, juice clearly does make a difference. So the games with no juice at all, the static versions, were never preferred. And games with juice were preferred in 5 of the 6 cases, whether that's the expert version or the generated version. We've shown that generated juice can make a difference as well. So generating effects for these games never harmed the perception of the game, and it improved it in a third of the cases, which is pretty good. And it was competitive with Mass's expert-designed attempts in many cases too. And of course, we need to do more research. So we're not beating Mass's work yet, and that's a good thing. It means that there's more work to do and more things to consider. Just a few closing thoughts before we finish this talk. One thing that we considered is that the challenge type probably impacts how people feel about juice. So for a 2-player strategy game, people probably want less juice. It's a more thoughtful game than kind of an arcade-style puzzle thing where you're playing on your own. We didn't really think about that before, but after the fact, we began to see that sort of pattern emerge. Juice also raises questions about what it means for a game design to be unique. So there are many different versions of Tetris with very different juicy effects in them. And if an automated game design produced a new version of Tetris just changing the juice, we're not sure how new that would be considered by other people. So we think the juice is a really important part of game design, but there's clearly some unanswered questions there, maybe from a computational creativity perspective, about which parts of a game design we rate more importantly than others. And finally, perceptual evaluation is tough. So getting Squeezer to understand what effects a player can perceive and which ones they can't was tricky. We had to do some filtering, and there'll be a lot more research there in the future trying to figure out how we can get Squeezer and Puck to understand what a player actually sees. Thanks very much for listening. If you want to talk to me or Mass on Twitter or via email, this is how you can do it. You can also play some of these games, and we've put them online at this URL here. And a little shout out to our friends in the Knives and Paintbrushes Collective, Eunice and Florence. Thanks very much for listening, and we hope to chat with you at AIIDE.